As we conclude with hyperbolas here, we're going to look at a specific type of word problem trying to apply hyperbolas. It's pretty challenging, and I don't even know if I would include this in the assigned portion of the book, but I'm going to go through it here in case I wind up doing it, or in case you need it for some other reason. So what they're saying here is that they have created this tower. We've got all of these dimensions, and they're asking us to find the equation for the hyperbola that fits this. So what they're saying here is, here's my bow tie, and this is the origin going right down the center. So the Cartesian plane is going right through the middle of this drafting, natural draft cooling tower, whatever that is. And I've got my bow tie, got my hyperbola going right and left. So we're going to build the equation for this. Now the first thing I'm going to notice here is that if I'm going right and left, then x squared is going to be first. Now the value of a, the only thing we really have here are the vertices. And so we have a vertice, since this is 60 all the way across, we have a vertice here at 30, 0 in the y, and negative 30, 0. Okay, so we know our value of a is going to be 30 because we're centered here at the origin and 60 across there. Now we don't have the minor vertices, so we don't know b. We don't have the foci, so we don't know c. And so what they're going to do here is that what we're going to know, we're going to use any other point on the equation for this to try to help us solve. And what they're telling us is we know this point here. So if this is 72 across the top, then half of that is 36. So this point right here is 3679.6. Can you follow this? So we don't have B or C because we don't have the foci, we don't have the minor vertice. So we're using any point off of the graph. Well, what point do we have? Well, if we know this height is 79.6, so this point right here, we know that its y value is 79.6, and if it's 72 all the way across and the axis is cutting it in half, this distance right there must be 36. So let's just walk through it here. Now they're going to take us through the rest. So we know x squared comes first. We know the value of a is 30. So far so good. Now here's where things get a little crazy. So we're going to use this equation and we're going to solve it for b squared. We don't have that, but we need it in order to complete the equation. So they've solved it for b squared. You get all this. Now we know the value of y squared. So this is the point. We're entering the point 3679.6 because it was on the graph. So y squared is 79.6 squared. X squared is 36 squared. And what else do we have? We had a squared, so we knew a was 30. So a squared must be 900. Okay, so I know this looks difficult, but all of this is just some simple algebra based on the facts that we already know. To solve for b squared, we get b squared is approximately 14,400. So we can put it all together. So this is a hyperbola equation. So x squared we were going right and left, so x squared is first, a squared is 900, and then that leaves us, we solved b squared and we get here. So there's our equation. Okay, again, pretty crazy idea, pretty crazy idea, but we're going to do exactly the same thing again. So we are going to work one. You're welcome to stop it and try this yourself if you want to. So my bow tie is going this way. I know it's moving along the vertical or horizontal axis, and so its x squared is going to come first. Okay, so what do we need here? We've got the value of a, so we've got the vertices here and here. So a is going to be, if it's 40 all the way across, a is going to be 20. So we know this is going to be, 20 squared is 400. So we know this is going to be 400 across here. Now, we don't have any other values, so we're going to have to use a point off the graph and do the same trick we did before. Well, here's the point that we have right here. We have the point, we cut this, it's 60 all the way across, but this point right here has an x value of 30 and a y value of 67.082. Does that make sense? So we know that it's over 30, because that's half of the 60. We're over 30, and we're up 67.082 because they told us that was the height off the diagram. So we need to solve for b squared just like they did right here. So we can even, this is our equation. So we're doing b squared is y squared over, so we could have done the same thing. They just rearranged this to solve for b squared. So in other words, they sent this over. Well, they went the other way. But yeah, but anyway, it's the same thing. They've already derived it for us. We could have done the same thing. So they've derived that for us to get this. Now we're going to put in our pieces. So we're looking for b squared. Our value of y squared is this guy squared, so 67.082 squared. And then x squared so we've got 30 squared being divided by a squared, which was 20, or 20 squared, and then all of that minus 1. Okay, so if we crunch all of this down, solve this, just be careful solving it. It turns out b is going to be 60. So we've got a and we've got b, so we've got everything we need to solve this. So b is 60, but b squared is going to be 3600. So here's our equation. So this was our a squared. We solve this, we get b is 60, so there's b squared. We knew x was first because our bow tie was going right and left. And there we go.